I have returned for the next part of our episode. You've now also been introduced to basic animation. The possibilities of animation are endless, as you've seen from previous episodes of our show. A robot which has a digital display has a wide range of additional uses. One of the most common uses of this technology is to display digital clocks to tell the time. And we can even turn Eve into one of those. Ever been a clock before, Eve?
I cannot say I have ever been a clock before.
Now, turning Eve into a full clock will take a long time. How long? Hard to tell without a clock. So instead, let's turn Eve into a timer. It's much more simple, and once you understand how to program a timer, you will someday be able to program a full clock. But first, there are a few new terms that we need to learn.
A variable is a piece of data temporarily stored by a program that can change while the program is running. A constant is a piece of data that is stored by a program that remains the same while the program is running.
So, in English, constants and variables are parts of a program, like the programs that Eve follows, that store information for Eve to remember. Eve will sometimes need to remember text or numbers as part of a program, like to put on his display. For this, you might want to use a constant, which is a piece of data stored in a program that never changes. But for this experiment, we need Eve to do some maths, namely counting down from 10. Counting down doesn't really seem like maths to anyone who knows how to count, but once again, we have to forgive Eve, because without us here to tell him very specifically what to do, he's basically completely lost. If Eve is going to be able to do maths, he's going to need to be able to change one number into another, like changing 10 into 9, 9 into 8, and so on. In order to do this, we need this information to be stored somewhere where it can be changed. So, instead of a constant, we want a variable. A variable is just like a constant, except that it doesn't have to stay the same whilst Eve is performing his commands. This will start to make more sense when I show you a constant and a variable in action. So, get back to your laptops, kids, and we can begin our next experiment. So to begin this program, we want to start out with a constant. The constant in this program, like I said, will be the number we are counting down from. We want to set that at 10. You will see from the options box on the constant block that it is set to numeric, meaning that it is set to remember numbers. The constant block can also be used to store text or logic-based data, but for now we are using it for a number, so we're all set. So if we go to the top right-hand corner of the constant block, we can make the value 10. Now we want to add a variable block. The variable block is not a variable itself, but we can connect it to one. The block has to be connected to a variable. This means that more than one variable block can be connected to the same piece of information, the same variable. There is actually only one variable in this equation, but we will be using many variable blocks to connect to it. So we want to create our variable with our first block. That can be done by going to the top right-hand corner of the block and selecting the Add Variable option. So we need to name our variable. Let's call it count, since that's what we are going to be using the information for. Now we can see from clicking on the Options tab here that the block can be set to either read or write. What this means is that now we have created our variable, it is stored somewhere in Eve's memory. At the moment it is blank, as we have not given it a value. Like a blank piece of paper, Eve can either write on or read the variable. So for now, we don't want Eve to read the blank piece of paper because there's nothing to read. So instead, we want to set this block to write, so that Eve can write something on that piece of paper and remember it for later in the program. Where are we getting the value for our variable? From the constant block. If you hover over this tab on the constant block, you will see that your mouse has turned into a spool of wire. You can now click and drag your wire between these two blocks and connect them. This is called a data cable. It feeds data out of the constant and into the variable. Think of it like a telephone line between the two blocks. Our constant is calling the variable to tell him his value is 10. So now we have our number 10 being fed from the constant to the variable block, which is writing this number into Eve's memory. Eve's piece of paper is not blank anymore because he has written 10 upon it, and he can remember that for later. Now we can begin building our program properly. We want to start the timer with Eve's display blank, so we should go back to the green blocks and add a display block to the chain of commands. Go to the options and select Reset the Screen. Now we want to attach a loop block. Inside this loop block is where Eve will be doing his maths to count down from 10. Before that though, we should place a sound block at the beginning of the loop block. This will make the ticking sound for our timer. If you click on the top right hand corner of the sound block, you will find the sound effects option, just like we did in the last episode. Under mechanical sound effects, there is an option called tick-tack. This will be the sound of our clock. You will hear a sample of it played after you select it. We now have three options. The first will cause the sound block to be played once before Eve moves on to his next command. The second option will allow Eve to carry on with his commands whilst the sound effect plays once. The third option will cause the sound effect to loop continuously. This is the one we want. Next, we need to add the actual countdown for the timer. This is where our variable comes into play. So, we take another variable block and place it in the loop beside the sound block. Go to the top right hand corner and select the count variable. This way we know that the variable block is connected to our count variable. Our first variable block that wrote down the number 10 on our piece of paper now passes it along to this next block, like passing notes in class. So what do you do when a note is passed to you? You read it. So this block we want to set to read because that is what it is doing. It is Eve's way of remembering the number 10. And now if we go back to the red data operations block, we can add this, the maths block. This is how we command Eve to do sums. So what number do we need our maths block to change? That same number 10 that's on the piece of paper. And who has that piece of paper at the moment? The variable block that just read the number. This variable block needs to tell the maths block the number he is starting with is the number 10. How can we do that? How about over the phone? We need another phone line between these guys, so hover over the empty box on your variable block and once again you'll have your wire. So let's draw that line. Now the maths block has the number 10 and we want it to count down to 9. So we need to have the maths block take away 1 from our 10. If you go to the options on the maths block, you'll see you can choose the subtract or minus option. This number in the middle here controls how much we are taking away from the number at the beginning of the maths block. That is already set to 1, which is what we want. Now, after this variable block tells the maths block the number 10, the maths block needs someone to tell the new number 9 to. Who better than another variable block? So, we need another variable block, and our maths block will tell it the new number over the phone. This means it will be receiving the product of the mathematics block, that being the number 9, since 10 minus 1 is 9. This new variable block, though, we want to set to right, because 10 isn't the right number for our piece of paper anymore. This variable knows to cross out 10 and write 9 on our piece of paper. And finally, we want to send our new number to Eve's screen so he can display it. So we are going to need a display block. But first, we need to think who will tell the display block what's written on the paper. Only one block has access to it, the variable blocks, and this one can't read and write. So we need another variable block set to read so that it can read the number 9 off of our piece of paper to the display block. So after you add a display block, you want to set up another telephone line, but there's nowhere for one to go on the display block. First, we must set the display block options to text, since we will be showing figures. Pixels is the best option in this case, as this will place the text in the center of the screen. This should result in the text automatically appearing in the center of the screen. But if this does not work, you can try changing the X value to 10 and the Y value to 5. These controls determine the position of the text on the screen. So now if you go to the top right hand corner of the display block and click on it, you will see the option Wired. Select this and now we can add a telephone line. And there you have your variables doing their job. They pass the information down the sequence of commands. And because we have the loop block here, the note that is being passed down the sequence will keep going around the loop. So it goes through once and 10 becomes 9. Then at the end, the note is passed back to the first variable in the loop block. And he puts it through the maths block again and it becomes 8. It goes through again and becomes 7. Then 6, 5, 4, and so on. Do you see? But we still have some finishing touches to add. Like with Eve's blinking, at this point our program is going to move too fast to see, so we need a delay block again. Take one of those and put it after your display block. This means the number will stay on screen for 1 second, like any good timer should do. We also want one more display block, also set to reset the screen, so the next number can appear in the last one's place. But what's a countdown without a big bang at the end? So we need one final output sound. Go to the actions and take a sound block. This is your alarm sound, so make it whatever you like. Lastly, we need to ensure that the loop only runs 10 times, otherwise your alarm won't go off. We could input the number 10 into the loop block's options, but why do that when we already have a constant remembering the 10 for us? So let's draw another telephone line from our constant to the loop block, and this means it will loop 10 times, and thus your program is ready to run. And there you have it. Eve is now a timer. Let's see it in action. Yes, that's right, Gottfried. Thanks to you, the future's going to be silver and full of crazy robot noises. Think about how, in time, robots could show us the entire universe, travelling through space without the need for food or oxygen. And this, Gottfried, this piece of that future, that's happening because you made it happen.
My Legos made that?
Yeah. Gottfried, are you going to be okay?
Yeah.
Come on then, let's get you home.
Oh.
Hello? Okay. Well, that's interesting. Alright. Okay, I'll see you in a minute. Who's that? It was people from my time. Apparently my part in the mission is done. I'm being called back. I mean, forward. That's me. But what if I need you? Will I ever see you again? Yeah, look in the mirror. Here, take these. I get the feeling you're going to need them. But listen, Victor. You have to get out of the lab more if you're going to spread the word of robotics. You have to get involved with this thing. You have to go where the action is. I will. Remember, keep the robot dream alive. Will you get out of here? See ya. Thank you very much for joining us, and we hope to see you again very soon. Well, Eve, looks like it's just you and me now. Though, I may start thinking about taking on some new staff. You have to go where the action is.
Where are you going?
Where am I going? I'm going to India.